Hey guys, I'm currently flying the quad we're gonna build today. And it's currently in position hold mode, and I'm filming myself with DJI O4 camera. So it's the build we're gonna do today. Please join me over the course of this video if it's something interesting. Oh, no, don't go, don't go, don't go, don't go. Hold on. So let's go with the video. This drone is mostly built from parts I already had at home, leftovers from old builds or from projects that never happened. The only thing I actually bought specifically for this quad was the frame and the LRS receiver. The components I used are FlyFishRC Volador Cat 5-inch frame. I have a separate video on the frame assembly if you are interested, the link is in the video description. DJI O4 Pro air unit, iFlight Xing 2 motors, 1855 kV, SpeedyBee F405 V4 flight controller and ESC, officially discontinued, but you can still find some stock on AliExpress. I bought a few earlier and this one is the last I had left. An active buzzer which I install later, Walksnail GPS module, RadioMaster RP4TD True Diversity receiver. As for prices, I bought everything with bulk discounts on AliExpress. Frame around €60, SpeedyBee stack €55, motors €50. I bought them a while ago, they might be around €10 more now. RadioMaster RP4TD receiver, around €24. It's a recent purchase, so price should be the same. GPS €15 and buzzer €7. That brings the total cost to around €212, not including the DJI O4. If you add DJI O4, it's roughly €240 here in Ireland and maybe cheaper depending on your country. I'll also include links to all components used in this build in the video description. These are affiliate links, which means I receive a small commission at no extra cost to you if you decide to purchase through them. I started with the question every quad builder eventually faces: where do you put the capacitor? On this frame, the placement seems obvious right here, but the capacitor that comes with the SpeedyBee F405 stack is quite large, and it just doesn't fit into that space. Annoying, because I really wanted the cap to sit there, and I didn't want to relocate it. So I ordered a set of smaller capacitors from AliExpress, which took another 2 weeks to arrive. Once they came in, you can see the size difference. The new one is shorter and finally fits into that tight space. But then another problem. Even though the smaller cap sits, the ESC overlaps the capacitor area, making it hard to lay it down cleanly. So I had to get creative. I wrapped the capacitor in Kapton tape for insulation and bent the leads to fit the shape of the frame. In the end, this is the layout I came up with. The capacitor slides in nicely, it's insulated and it fits the space. Not perfect, but it works, and this is how the capacitor will be mounted on this build. SpeedyBee stack originally comes with 12 gauge wires, but I am switching to 14 gauge. That's perfectly fine for this quad. The motor setup and the current draw don't require anything thicker. That extra millimeter of wire diameter actually matters here, because the wires need to fit into that very tight space on the frame, so 12 gauge is too bulky, but 14 gauge fits just right in the channel provided for the power wires. The motors look great. I really like the color and the shape of the bell, but we won't spend too much time on the motor installation. Let's quickly go through the process, adding the screws, routing the wires through the protection tubes, and soldering everything in place. Once that's done, the motors are installed, soldered and ready. A quick cleanup with isopropyl alcohol and we can move on. Next, it's time to install the flight controller and flash the software. I'm loading Betaflight 2025 RC2, which is the latest release candidate at the moment of the recording. I'm also flashing Bluejay onto the ESC to enable bidirectional D-shot. To flash Bluejay, we need to connect a real battery so that ESC configurator can read and write the ESC settings. I'm using the latest Bluejay firmware at 48 kHz PWM and then flashing it. In Betaflight, we will set up the motors. I'm running props out and enabling bidirectional D-shot. Then we configure dynamic idle. The RPM of my motors at idle is about 3.6K at 1055 throttle value, which is our 5.5%. So I enter that value RPM divided by 100 into the dynamic idle setting in the PID tuning tab. With the motors and ESC configured, we can continue assembling the rest of the quad. Confession time. I buy every single part for all my builds with my own money. And I need your support. No, I don't need GoFundMe or Patreon. The only thing I'm asking is to like, subscribe, and leave a comment. That helps to grow my channel, keep it alive, and it also helps me to explain to my wife why I need another set of motors rather than for us going to restaurant. Thank you very much. Cheers. After thinking a bit more, I decided to rotate my flight controller 180 degrees. Normally the arrow points to the front, but in my build it's now pointing to the back. The reason is simple. My GPS and buzzer will be mounted at the front of the quad, and I2C solder pads for compass and the buzzer are located there. The receiver, on the other hand, will be mounted at the rear, and the receiver pads are also now on the back of the board. So flipping the flight controller makes the wiring much cleaner and avoids awkward cable routing. Luckily, SpeedyBee F405 comes with a nice long cable which makes a 180-degree rotation possible without any issues. While I was waiting for the capacitors to arrive, I spent some time planning the components layout on the drone and doing some modeling. I ended up creating a few custom TPU prints. For example, this antenna mount is a remix of standard FlyFishRC TPU mount, but I added extra antenna protection. I also made a mount for the ELRS receiver, a GPS mount, and a buzzer mount. We will install each of these as we go through the build, and if you are interested in the STL files, I'll include links to the models on Thingiverse in the video description. Next up is the buzzer. I am using a small one, literally the only buzzer I had at home. It's not very loud, but that's what I've got, so we are rolling with it. I designed a custom TPU mount for it. The buzzer slides into the printed holder like this, and the wiring comes out on the side. The whole mount attaches to the frame using cage support carbon plates. The 3D print is shaped so it fits snugly between them and stays firmly in place once the frame is assembled. Time to install DJI O4. The camera goes into its usual position inside the cage. I am securing the buzzer using the second carbon plate that supports the camera cage, and then fixing the whole camera cage onto the frame. Once the screws are in, the camera sits nicely between the cage plates and the buzzer is held firmly in place. The only annoying part of this setup is the buzzer button. You need something thin to press it each time, but honestly I couldn't find a better place to mount it. Next, I am lifting the flight controller slightly and routing the O4 camera wire together with the O4 data cable between flight controller and ESC. I really don't like having wires running over the top of the flight controller. They are constantly rubbing against the battery strap, and over the time that can damage the insulation or even break one of those tiny soldering joints. I also realized that 14 gauge battery wires are still too thick for the digital modules to sit flat on the frame. Luckily, I had some rough 3D printed spacer bars from prototyping. They are not too pretty, I was too lazy to reprint smoother ones, but they are 3mm thick and do the job. With those in place, I can secure the O4 main module using M2x10 screws. Then I plug in the data cable into DJI Air unit. I'm not attaching the antenna yet, I'll do that later. And that's how setup looks now. The raised O4 module means I can't use my original 3D printed receiver mount anymore, so I'll need to come up with a new mounting solution. Next, XT60 connector. First, double check your connection polarity. If you get it wrong, you risk burning your VTX, ESC or both, so make sure the positive and negative pads match the connector before you touch the iron. Next, cut your wire lengths and carefully remove the insulation. Don't nick the copper. Gently slice the insulation and pull it off with your fingertips. Add a bit of a flux and tin the 14 gauge wires, then tin the XT60 connector pads as well. Before soldering, don't forget to slide on the heat shrink tubing once the wires are soldered, it's too late. Now solder wires to the XT60. After that, shrink the tubing with the heat gun to secure everything. And here's the final result, our soldered XT60 connector. Next in the queue is the ExpressLRS receiver. I've already soldered the wires and plugged it in into USB, so now I'm flashing the latest ExpressLRS firmware. This is RadioMaster RP4TD True Diversity receiver, so in ExpressLRS Web Flasher I select the correct target, enter my binding phrase, and there is nothing special needed in advanced settings for this build. Save firmware file to PC, connect to the ExpressLRS Wi-Fi network, upload the firmware and update it to the latest version.
Telemetry connected.
Once it's done, I add a heat shrink. And here is the final look of finished receiver. With the receiver ready, it's time to assemble the back of the quad. I remove the screws from the DJI O4 Air unit and use my TPU antenna mount to install the DJI antennas. Be careful not to stress the thin cable coming from the top cover of the Air unit. I put the 3D print into position, secure the antennas and mount XT60 connector on top. That's how the rear section looks so far. Now I install the LRS receiver. I 3D printed a new holder. Remember I had to raise Air unit and my previous design doesn't work. And that new holder mounts under the O4 screws, so I use longer M2x8 screws with a bit of Loctite to secure everything. Now the receiver sits nicely in place. Next, I position the receiver antenna so they are out of the way while I finish the build. It's roughly their place, but it's not a final alignment. I'll fine tune it once props are on. And now it's time to solder the receiver and buzzer wires to the pods, and followed by a bit of cleanup with isopropyl alcohol. Next up is the GPS module. I solder the GPS wires to their pods on the flight controller and then mount the module using my custom TPU sandwich mount designed specifically for the Walksnail GPS. That keeps everything tight and secure on the frame. Now it's finally time to complete the assembly and install the top plate. I'm using the 3D printed standoff ratchet that came with the frame, not entirely sure what the real purpose is, probably some kind of shock absorption, but I'm installing them anyway. Then I secure the top plate with the included screws. With the top plate in place, I mount the GPS on top. Looks good, doesn't it? Next one is very satisfying. I remove the protective film from the DJI O4 lens and install ND filter. This is a FlyVoo ND8 filter I had lying around. It's mainly to protect the lens, but the ND filter is a nice bonus. Time for battery straps. The frame includes two straps, one short and one long. For a 6S battery, the long one works perfectly. The shorter strap is more suited to a 4S pack. And here's how it looks installed. Now to the props. I'm going with Gemfan Proxy Pablo Floor low pitch props in the whiskey color. And here's the quad with the props mounted. Finally, let's put it on the scales. 456 grams, give it or take, that's the weight of the full build. Let's quickly run through the rest of Betaflight setup. In the port stuff, we have UART1 talking to O4 air unit, UART2 we have our ELRS receiver, and UART6 we have our GPS module. Configuration tab. I set the board alignment to 180 degrees yaw since my flight controller is rotated. I have magnetometer alignment set to 180 degrees and specifying the flip matching the physical orientation. And I have arming range set to 180 degrees so I can arm in any position.
Failsafe tab, I have GPS rescue enabled and pretty much everything else is default settings. I also have throttle and aux2 set to 1500, which means if drone goes into failsafe, first it goes into angle mode immediately during the failsafe phase. And second thing, I am increasing throttle to 1500, so my quad is going a little bit up. Maybe I'm behind obstacle, and that could save me. On a P-tuning tab, I've added a small amount of expo to rate profiles, and everything else is stock to Betaflight settings. Receiver tab, nothing fancy, all set during binding. On the modes tab, my usual switches. GPS is enabled and working. Motor stack we've covered earlier. My OSD layout is pretty much my standard layout, so nothing fancy here. And that's pretty much it for the Betaflight configuration. Simple, clean, and nothing fancy.
Let's review a few outcomes from the test flight. First of all, with the compass properly calibrated, I can now switch into altitude hold and position hold almost immediately. As soon as I flip the switch, the quad locks in perfectly. To demonstrate the compass accuracy, I did a quick orbit around myself. Of course, I took a chance to enjoy some nice views of Dublin Bay and Dublin mountains. For this flight, I had an ND8 filter on the quad. It wasn't a super sunny day, so it was mostly there just to protect the camera lens. The footage you are seeing is from the goggles, not from air unit. I didn't have a spare SD card on me at the time, but honestly it still looks great. I also tested a new battery. It's 1350 mAh 6S 140C Gen V battery. You can see it in the assembled drone overview. With non-aggressive flying, I was able to get over 10 minutes of a flight time, which is fantastic for this setup.